Namaste. Welcome to Indian Knowledge Systems Primer Course for Children. In the series of lecture on Indian astronomy, in this session we will be looking at the Indian calendrical system. We will try to understand the depth and breadth of it in this lecture. The calendar generally serves it has a very fundamental purpose in our lives. We coordinate all our activities, even the societal activities, by marking the passage of time. We would, very simply we would celebrate our birthdays, we will have specific functions, all of them is mapped with the calendrical system. This is not just in our personal lives. For example, things that are involved with the society at large, such as planning of agricultural activities, scheduling a religious ceremony, and celebrating different events, all of them, even coordinating civil matters, all of them require for us to have a detailedly scheduled calendrical system. In the Indian culture, the importance of the calendrical system is very deeply entrenched because the Indian calendrical system is a reflection of the lunisolar calendar, which means there is a very close relationship. The association is very close between the societal activities and the astronomical events. What we are trying to say is that the Indian calendrical system, which is necessarily lunisolar, maps the social or the societal events with the astronomical events, so that we have a quite precise reckoning of time. What is the significance? We will try to understand with few examples. From the Vedic times itself, even for celebrating specific rituals or ceremonies, we used to mark time specifically, and these will be mapped based on the celestial events, because it has always been an observer's point of view, from the observer's point of view. The various phases of the moon, solstices, all of them are embedded in the Indian calendrical system. Even today, when we celebrate Deepavali or Diwali as it is called in North India, it is marked as the day when the new moon sets in the Ashwina Masa or the Kartika Masa. Ashwina Masa in the Amanta system and Kartika Masa in the Purnimanta system. We will try to understand what is Amanta and Purnimanta a little later in this session itself. So this is with respect to Deepavali or Diwali. With respect to Holi, it is celebrated on the full moon of Falguna Masa. All these masas are very specific to the Indian calendrical system. So that is why when we try to see these functions, they fall on different dates in the Gregorian calendar that we very commonly follow these days. Because Indian calendrical system it operates very closely with the astronomical events, whereas the Gregorian or the Western calendrical system, it's more of an arithmetic calendar. So the Indian calendrical system, they're all based on the lunisolar calendar, aligning with the astronomical events. That is why they do not come on the same date as that of the Gregorian calendar. So we can understand that our Indic functions, they fall on very different dates when we map it to the Gregorian calendar, because the Gregorian calendar necessarily is an arithmetic calendar. It's more of a set of rules and calculation. But the lunisolar calendar, which is very specific to the Indian calendrical system, is very closely aligned with the astronomical events, and hence this mismatch will always be there. We will try to see more about what a Gregorian calendrical system itself, so as to appreciate the depth and the richness of the Indian calendrical system. Furthermore, we would have seen even in disciplines such as Ayurveda, you would have seen in the previous lectures of Ayurveda that specific times are always mandated upon. You will follow Dinacharya routine tightly coupled with a specific time of the day, and this time of the day is mapped with the sunrise and sunset or some sort of an astronomical event. For example, Brahme Muhurte Uttishta. So you'll have to wake up early in the morning, Brahma Muhurta, which is 45 minutes before the sunrise. That's how the time calculation and the calendrical mapping happens. So we can understand that the calendrical system is not just about marking the time alone, but it is a reflection of the society's relationship with nature, and it provides for a very deep scientific understanding and very rooted in the cultural practices that is common to the Indian ethos. Now, let's try to understand what are all the different categories or different types of calendrical system that are prevalent in current times. So, broadly the calendrical systems are divided into arithmetic calendars and astronomical calendars. We just saw one example each. We saw that arithmetic calendar example being the Gregorian one, wherein it is defined by a set of rules and not per se aligned with astronomical phenomena. I mean, astronomical phenomena would have been taken as a consideration, but then they would have formed a set of rules and they very strictly are tightly coupled with those set of rules. The arithmetical calendar happens to be this way. Whereas astronomical calendars, in contrast, for example, the Indian lunisolar calendar are very tightly coupled with the actual observations of the celestial bodies. So, they are very tightly coupled. If there is going to be a change there, that will definitely be reflecting in the lunisolar calendar of that particular year. So, we can understand that these astronomical calendars actually would be able to tell the movement of the sun, the moon, the various planets. They take in all of these data to determine the days, months and years. The position of the stars are also taken to determine days, months of the year, months and the years. So definitely these calendrical systems will be more complex, but they are also actual reflection of the celestial events. Thereby, they offer a very sophisticated and accurate way of or accurate solution to timekeeping and time reckoning. That's an important aspect to remember and appreciate. Now, let's try to understand how this arithmetic calendar came into being, or rather how we inherited this arithmetic calendar. There was once a Roman calendar which was later revised in around 46 BCE by the Roman general Julius Caesar. He modified it, he made few revisions based on the solar cycle. Then you see the mean tropical year, which is what is the tropical year, which can be calculated as roughly the time between one vernal or an autumnal equinox to another vernal or autumnal equinox, or the time period between one solstice to another solstice. Basically, the earth would have completed one full rotation, one full revolution around the sun. So, this was very accurately calculated as the amount of time taken for this is the mean which is a mean tropic year has been calculated as 365.24219 days, which is nothing but 365 days, 5 hours, 46 minutes and 45 seconds. This was sort of approximated in the Julian calendar to 365.25 days. So, what have we done? We have made it into 365 days and a quarter day. So, this quarter day which gets accrued every year, which gets added every year is what reflects in your leap year calculation. So, that is why what they did in the Julian calendar, once in every 4 years, they will add an extra day to the February month. But in order to, this compensation was okay, but there was one more additional day which was getting added wasn't so accurate. But this Julian calendar also was way too long. It was long by 0.0078 days, which is about 11 minutes and 14 seconds. One can think this 11 minutes 14 seconds is a very small error, because it was longer, because we did an approximation of 365.24219 to 365.25 days, which is what became as that one extra day getting added every 4 years. But this addition itself was way too long of an approximation because of every year that 11 minute 14 seconds was extra. This seems very negligible. If you see it on an annual frequency, this is a very, very negligible amount of time. But this 0.0078 days is very negligible. But imagine what happens if the same calendrical system is followed for like 1 century. Then we are errored. The calculation has an error of almost 1 day because 0.0078 into 100 becomes 0.78 days, which is almost a day. So, by the time it was 1500, the vernal equinox, which is falling around, on March 11th, it started to fall on March 21st as per the calendar. Now, this was also a problem for a lot of Western religions because they observe a lot of religious practices during the equinoctial time. So, to sort of adjust this, in around 1582 CE, Pope Gregory the 13th adjusted the calendar by moving the date ahead by about 10 days because the equinox was getting measured on March 21st because of the 1 day, extra 1 day getting added every century, error 1 day. So, he sort of pushed about 10 days in 1582, which is still not a good calculation because there is also a lot of approximation getting involved. So, the phenomenon of equinox, which was supposed to happen on March 21st, started happening on March 11th because we pushed it, the Pope pushed it by 10 degrees ahead, 10 days ahead. Because there has been an accrued error of 1 day every 100 years, and so he did this. He cut about 10 days after October 4th and between October 4th. After October 4th, he cut 10 days and then he had only October 15th, which was introduced in the calendar of 1582. So, if you even check in any of your apps, any of your mobile apps or any calendrical apps, you will be able to see that in the year 1582, after October 4, you will not have any dates. You will only have October 15th directly. That's quite a huge jump, isn't it? So, the Pope made a critical correction of pushing the date ahead by 10 days so that the vernal equinox will fall on March 11th instead of March 21st. For what he did is that from October 4th, it directly jumps to October 15th in 1582. There is one more second correction that he made. What did he do? He said that once in 4 years, when the leap year calculation happens, we will add 1 day. But when it comes to centuries, so 1900, 1800, 1600, such type of centurial calculation, he said that it has to be divisible by 4 and then also divisible by 100. So, 4 into 100 is 400. So, that century year should be divisible by 400. Only then it can become a leap year. For example, 1900th century is not a leap year, according to the second correction introduced by Pope Gregory the 13th. So, owing to this, what happened? This correction brought the average length of the year to 365.2425 days, which is still not exactly the truth of 365.24219, but it's still very, very, very close compared to the huge error that the Gregorian calendrical system was already facing, because once in a century, 1 extra day was getting added in the Gregorian calendar. So Pope did these two corrections to sort of make the arithmetic calendar work appropriately. So, it will take about, is it flawless now? No. But what we have done is sort of reduce the margin of error. So, what will happen now? So, it is going to take about 3300 years for the Gregorian calendar to gain 1 day, which is a error extra day. So, it is going to take about 3300 years. Previously, it was 100 years, and then now because of these two corrections that the Pope made, now 3300 years it has to take. The Gregorian calendar will go through 3300 years and then it will gain one error day as an extra day. So, for example, in 2023, the error accrued so far, by the Gregorian calendar is about 0.1364 days. This amounts to about 3 hours, 16 minutes and 25 seconds. In contrast to all of this, the Indian calendrical system, like we just saw, is not just arithmetic, whereas we just count the days based on, we develop, few set, standard rules and based on a few astronomical events, but not so very tightly coupled with them. But in the Indian calendrical system, which is also referred to as the Hindu calendar by the earlier researchers, is entirely astronomical event driven. It's tightly coupled. It follows a lunisolar model. We will now try to understand the lunisolar calendrical system deeply. Then we will be able to appreciate its sophistication. So, as I was saying, this lunisolar model astronomical calendar is very sophisticated, highly sophisticated, but it is also computation intensive. It's very complex, requires a lot of calculation, and but the very critical aspect is that it is very, very, very close to the reality, the astronomical reality. Hence, you will have a precise reckoning of time, which is the whole purpose of following a calendrical system. And hence, we can see that it's quite elaborate, complex, but still sophisticated and very precise. So, broadly, the lunisolar calendar has two parts. The lunar part, wherein we will track the movements and the aspects and especially the time aspects related to the moon, and the solar part, which is wherein we track the movements and the aspects related to that of the sun. So, the lunar calendar will be entirely based upon the monthly cycles of the moon, which means we can calculate from one full moon to another or one new moon to another. It is basically based upon the cycles of the moon. These are also called as synodic months. Synodic is an important term, which means that this phenomenon sort of repeats again and again. It is talking about the frequency, synodic months. There is a cycle. So, one cycle of calculation will be measuring from one new moon to another. This is called as the Amanta system. This is a very ancient system. This is called as the Amanta system or Mukyamana. Otherwise, it is called as Mukyamana. And the second calculation in the lunar calendar itself is that of measuring from the one full moon to another full moon, which is called as the Purnimanta system or the Gaunamana system, which counts from one full moon to another full moon. We can understand that we are already seeing a lot of diversity, and even in India, across the Indian subcontinent itself, there is a huge diversity in the calendrical system, because a few regions and a few part of India will be following the Amanta system, a few will be following the Purnimanta system, and a few would follow both the lunar and the solar aspects of the calendrical system. We will try to see which regions follow what. So, if you see the Amanta calendar, wherein we measure the synodic month from one new moon to another new moon cycle, regions of Maharashtra, Karnataka, Andhra Pradesh, Telangana and some other regions of Gujarat, all of these follow the Amanta system. Whereas Uttar Pradesh, Bihar, thereby Jharkhand, Uttaranchal, Madhya Pradesh, Rajasthan, Haryana, Kashmir, all of this follow the Purnimanta system. But the other regions of India, such as Tripura, Assam, Kerala, Tamil Nadu, Bengal and the northeastern states, all of these, they follow a solar calendar for dating and they use the Amanta system for fixing religious festivals. Can you now see? Look at the intensity of calculation and the precision that they have worked on developing such sophisticated calendrical system. So, what do we say? So, Amantha system would be followed to sort of fix the religious festivals, which means the, it is basically associated with the astronomical event of the moon to be in a particular place and the sun to be in a particular place. All of this is taken into account in the lunisolar calendar system. So, you can see there is a huge diversity in the calendrical systems. In fact, it is said that there was 15 plus variations of panchangas that are being alive, which are active now and are available and are also followed very rigorously. We will now try to understand what is a panchanga, what is this richness or what is the diversity principle that is available in the lunisolar calendrical system. So, in the lunar calendar, what would be the components? Okay, let's try to understand one by one. In a solar calendar, it's based upon the annual cycles of the sun, which is basically the tropical year counting. But it will have like about 12 synodic months, that is 12 synodic lunar months, making it to count for about 354 days, 8 hours and 48 minutes. Okay, which is about 354.367056 days. This is the lunar year. So, solar year is where we calculate the one full revolution of Earth around the sun, but it will include the lunisolar calendar. This is being mapped, but it will include 12 synodic months. The synodic lunar months will be calculating the moon cycles and they will have roughly about 354 days, 8 hours and 48 minutes. Whereas, we can now see there is a difference. This is not actually equal to the time that we had proposed earlier. We said no, 365.24 to something. So, it is not even close there. So, what happens? There is so hence in the lunar calendar, we lose about 11 days relative to the solar calendar, right. So, you are following the sun's revolution path, you are following the revolution time that is taken by the earth to complete one full round around the sun. You are trying to do this, but you are dividing the months through the lunar cycle. By doing so, there is an extra 11 days available. So, what happens? There is an adjustment that will happen once in about every 3 years or roughly 2.9 years. So, every 2.9 years, we will have an Adhika Masa, meaning an extra month that will get added. So, do you see the periodicity here? This is not like a jump and error approximation technique. No, we have clearly acknowledged, because we are trying to follow both the solar and the lunar cycles, wherein the lunar cycles will account for the month calculation and the solar cycle generally will account for the year calculation. We are seeing that every year there is 11 extra days, and these 11 extra days are accrued once every 3 years and an Adhika Masa will come into play. In fact, we are recording this video in an Adhika Masa. So, we can see that such periodicities have been noted and accounted for. So, this is like a very clear formulation. So, you do not need anybody to intervene once in 100 years or once in 3300 years to sort of change the calculations, because all of these are also closely coupled with the, tightly aligned with the lunisolar events, or rather the astronomical events. We will try to understand more details of it a little later. But we must also appreciate that the lunar months or the lunar year itself was short of the solar year. That is why this calculation of extra 11 days and the Adhika Masa had to be added. But we see that a lunisolar calendar very sincerely strives to put these two events or pack them both into one calendrical system. It captures the motion of the sun, it captures the motion of the moon, It measures for the both sun and the moon cycles. It indicates both the phases of the moon, the time of the solar year. All of this are accounted for in the Indian calendrical system. Isn't this quite, look at the enrichment of details. Rich details are present in the calendrical calculations, and hence, albeit it will still be very precise. So, now we will try to understand how do we go about presenting this calendrical system. There is a book, a very important book that you would have all seen, which gets published every year. If you have seen your parents and all that, they would have this usually placed in the altar of your house or somewhere wherein you will do the puja. So, it's called the Panchanga. This is a it's a highly scientific, mathematically accurate book of knowledge. We will know how now. So, it's an important book that gets published every year, and it is a very basic book for the society, giving the calendrical information of various nature on a daily basis. So, all of these calculations, the great Indian astronomical scholars, they will sit and do and publish this book, so that people at large can arrange their events, all the events, be it agricultural events, be it fixing ceremonies, marriages, birthdays, all of this can be, even the civil works, all of this can be aligned and with the astronomical events for anybody. So, the people can take up the Panchanga and they will be able to see, understand and map a day for a specific religious rite or things like that. So, this book can be used by society at large. It will have various information. Even on a specific day, it will tell when will the sun rise, when will the sun set. It will give those specific timings. When will be, what is the transit of the moon, what is the Rashi in which the sun is present at that time, what is the nakshatra in which the moon is present at that time. All through the positioning of the nakshatra, it will tell where the moon placement is. All of this, including the calculation of solar and lunar eclipses, are also mentioned in the Panchanga book. Isn't this all very fascinating? Look at the depth of knowledge and the calculation. Such complex calculations were made when they did not even have such sophisticated supercomputer system and all of that. They were able to make such complex, high intensive mathematical calculations very tightly coupled with the astronomical events, so that the calendrical system will be close to the truth. So, all of these have been recorded very diligently, very sincerely. So, you can understand that it is a very precise ancient tool, the Panchanga system. So, the earliest known Indian astronomical work is that of Vedanga Jyotisha, written in 14th century BC by Maharishi Lagada. And the very recent book, if you see in the Indian astronomical system, is that of Siddhanta Darpana, written by Samanta Chandrasekhara. All of these, from that book to this book, there has been a continuous evolution process. It has been the Indian astronomical calculations, they have continuously evolved from 14th century to 19th century, and it has always been very diligently followed, pondered upon, and has been revised appropriately. So, as we had mentioned earlier, there were 15 different calendrical systems that are even prevalent till date. So, there are a lot of diversity in the calendars, and all of this should not bog one down, but we should be able to appreciate this richness. When you are adding so many details, so many precise details, only then, when you are enriched with data, only then you will be able to arrive at accurate conclusions. And that is what all of our Indian astronomical scholars have strived to do. You should be rather inspired by the deep understanding of these principles, how deeply they have understood the astronomical events, the need for such a robust yet precise calendrical system. All of this should be appreciated for. and the understanding in the mathematical foundation that underlie the Panchanga, the deep understanding that should also be appreciated and inspired from. That's what we are trying to do by this course as well, to give the eye of appreciation for such a long standing tradition which has been very deeply scientific as well. Now, let's go on to understand fundamentally what a Panchanga system is. How do we, what is it, what does it do, how is the calculations done, how is it presented for the common public to sort of make use of such sophisticated tool. We will try to understand. So, the word Panchanga is derived from Pancha meaning 5 and Anga means limb. So, the Panchanga is basically a 5-limbed Hindu calendar. It will be primarily capturing 5 aspects. What are those aspects? Vara, Tithi, Nakshatra, Yoga and Karana. Repeat with me. Vara, Yoga, Tithi, Karana and Nakshatra. These 5 aspects will be calculated and measured and presented in the Panchanga book. We will have very deep dedicated sessions to delve deeper into each of these concepts. What is a Vara, what is a Tithi, Nakshatra, Yoga and Karana. We will have that in the course of this lecture in the further upcoming sessions. But today in this part we will very quickly try to understand what each of these aspects mean. If you see Vara is roughly the day of a week and Tithi represents the lunar day. So, from new moon to we will say Krishna Paksha, Shukla Paksha, all of this we will try to understand in the upcoming lectures. So, the synodic month, that lunar day is specifically measured using or is covered by the Tithi aspect. The nakshatra represents, the nakshatra part represents the moon's absolute position in terms of the lunar constellation. Where is moon placed, mapping it with the star position. That's what is nakshatra. It helps us to find the position of the moon basically. Yoga is more the combined position of the moon and the sun. The aspect of yoga here in the Panchanga will deal with the combined position of the sun and the moon. And Karana is a half moon day. That's what is Karana. So, we have tried to very quickly understand what these 5 aspects which are necessarily captured in the Panchanga document mean. We will delve deeper into all of this in the upcoming sessions. So, we can now understand that the principles of each of these mathematically are quite very deep, complex, sophisticated. So, let us be awakened to all of these astronomical principles that underlie them in the upcoming lecture.